All right, guys. So we are picking back up in our series on learning programming through Python. And today we're going to continue with the programming exercises that don't require loops or iterations. So the practice for functions and variables and conditionals here. And so last time we had gotten through this one that deals with getting the middle value from a set of 3 input arguments as integers. And now we're on the second function that deals with basically reversing someone's name given an input list that contains a family name and a personal name. Because depending on what culture you're from in the world, sometimes people put the personal name first and sometimes people put the family name first. So that's where we'll pick up today. And as we do these practice problems, Audie can go ahead and try them on his own first, and then if we get stuck, then I will help. So do you have any initial questions here, or you just want to go on your own?
With the problem, right? I had solved it before we met today, so I'm trying to do that right now. Yeah. So
if you look at the documentation for the list.index function, I think this function may return. Yeah. So it says that it returns the position at the first occurrence of the specified value.
yeah.
So that's why you were getting errors, because it was actually looking for the value 1 in the list.
Yeah, and the value 0. Yeah, I just checked and saw that I was making that mistake. So I've removed that and I'm using the reverse method now to work on it. And next thing I want to do is make a string out of that. I hope I'm right about this. Do I need to do something else?
So are you thinking right now?
And I was actually checking something. I wanted to make sure I got the syntax right, and I think I did with the reverse method. So next is to print string.
So I'm playing music right now. That's not coming through, correct?
No, it's not.
Okay, good. That's what I wanted to make sure.
Okay. Okay, let me ask this question. This in the Japanese name list, Isoroku would not necessarily be in the list. They can be inputted by the user, right? So it wouldn't necessarily be there. So I can't actually use those names to work with this.
I mean, you can't hard code it if that's what you're asking.
Yeah.
Well, I mean, well, actually, in this case, you could, but we want this to work for any Japanese name, not just this one, right?
Yes, yes. So what I'm trying to figure out now is how to create placeholders for the two strings. I don't know if that's something I should go on to do.
Do you want to explain to me what you were trying to do when you were using the index function earlier?
Yes,
because you're kind of on the right track.
Okay. Okay. So what I was trying to do was to basically extract the elements in the list and make them into variables. They would actually respond to specific variables. I would create variables that I would assign those elements to, and I could use those variables to create a string and concatenate the strings to create the Western style name string. That's what I wanted to do.
Mm-hmm. So that's the right general approach. But then the question is, how do you get things from a list?
Yeah, that's what I'm trying to figure out, I guess. Mm-hmm. Okay, so let me see.
So there's a specific syntax for it. We've talked about this.
Okay.
I'm trying to come up with what I can say without just giving you the answer.
Okay.
Like, do you remember how we talked about how you could go, you could get different ranges of things?
Yeah.
Like you could get just the first one.
I would have to use a for loop. Yes.
That's not what I'm thinking of.
Okay.
What I meant was like how you could get all of the things in the list except for the first one, or you could get all of the things in the list up to but not including a certain number of things.
Yes. Let me see.
Do you remember when we talked about that? I mean, you can cheat. You can scroll back up and look.
Yeah, I'm doing that now anyway. So just give me a minute. I think I'll figure out what you're writing. Okay.
So you're close. I'm assuming you figured out that when you print Western style name string, you're not getting the right thing. Is that correct?
Yeah. Yeah.
And so have you checked in the debugger? Do you know what the values? Okay.
No, I haven't. I'll check in a second.
Well, I think you're figuring it out right now.
I wanted to make sure first. I didn't want it to end up printing something. Okay.
So how are you checking the values right now?
I'm actually not checking. I'm just thinking about going through. Okay. What I did at first was I was concerned that if I did what I've just done, it wouldn't print a string because this plus sign would not make sense to it. But I can't put this in quotes because that would make this the string first name instead of actually a variable that it's supposed to fetch and use.
So when you say that it won't know what the plus sign means, what exactly do you mean by that? You mean like how numbers, it tries to add numbers, and strings, it tries to concatenate strings. So
yeah. So I figured it might not recognize that what I'm telling it to do is to put two strings.
So up here, when you say first name is equal to the element of index 1 of the Japanese name array, the thing that runs your code is called the interpreter. Okay, and so what kind of thing is this right here? Is this index in the Japanese name array? This isn't a trick question, by the way.
Okay. What are you asking me specifically? Whether it is, are you asking what's
basically, yeah, what data type is stored in the first name variable after this line has been executed?
String.
Okay. And how about the last name variable?
A string too.
Okay. And so when the plus operator is used on two strings,
it will concatenate them.
Right. So do you think we need to actually tell? Think we actually need to tell the compiler anything?
No, we don't. We don't.
Now it's a good thing that you're thinking like this though, because if we were to do something, I'm gonna take over here. If we were to do something like num1 equals 5, num2 equals 10, 3 equals num1 plus num2, and what we had intended was to concatenate so that we have 5, 10, this code will not do that. This code will return 15 instead.
Yes.
And so if you want to do that, what you would have to do is you'd have to turn both of them into strings first. This. Does that make sense?
Yes, that makes sense.
Okay. Now, of course, the smarter way to do this, if you never need to do anything with these numbers, is probably just to define them as strings to begin with. But usually the situation for this, well, actually, maybe not this one specifically, but if you have a function that operates on certain data types, then you need to remember to convert those things to strings if the function that you're using expects strings. So your instincts are not really terribly bad here. but that right here, what we just talked about is the reason why we don't actually have to do anything for these specific values, because they're already coming into us as strings from the list.
Yeah. Yeah. So, okay. So why is it not working? Why is it not printing anything right here?
So have you printed anything with a print statement?
Oh, no, I haven't. But, oh, right. So then when I call the function, anything, because I didn't tell it to print anything. Okay.
So where do you think it would be good to check our values? And here's another thing. Right now, you're calling the function on line 289.
Yeah.
When this function returns, what does it return?
It just returns the string.
Okay.
The first string, that's all it does.
And are you storing that value that it returns anywhere?
Yeah, Western style name string, right? That's the variable I'm storing it in.
Is that defined outside of the function?
No, it's not.
Okay.
Okay.
So let's do this two ways. Let's first check the values in your function by printing, and then let's check them in the debugger without printing. Okay. So printing will work fine, but it requires you to change your code, but to put print statements in. The debugger will work without you needing to change your code. So you don't actually need to save the value. I was just pointing this out on 289. If this call on 289 is going to return a function, how can you print this? Rephrase it that way.
I'll go back into the function and actually write a print statement there. And let me see.
That's not going to return anything then, because the print function itself doesn't return something. So if you want to print it before you return it, that's what we want to do, right? We still want to return the same thing, but we also want to print it. Yeah. Okay, now when you're in global scope, the other thing this function was supposed to do was to reverse the order of the list, right? And we want to make sure that it does that, not in some local variable, but that it actually reverses the order of the list that is passed into it. So that print statement, it might be best to check that one outside of the function itself. Do you understand what I'm saying?
Not fully.
Okay, so if you were, rather than using the reverse function, which you agree should operate on the thing that we pass into it, right? It's an operation, just how insert is an operation or append is an operation. It should modify what's coming into us, because you didn't use assignment here. Well, if you did use assignment, and then you were to, after using assignment, just print the value of the variable that you assigned, that variable would be correct. However, it wouldn't be meeting the what the function was supposed to do, right?
Okay.
So let me, for a sec, explain what it is I'm talking about. So let's say that instead what you did was this. Now, this is not what you should do, but this is a way in which someone might go about thinking that they should do this. So Japanese name, and then they would do the first index, then the second index, or the first, well, okay, that's confusing. Index 1 and then index 0, like this. And then we should reassign this.
I understand it.
Okay. So if we do this, inside of the function, this will have the correct value, because what we've done now, this is what we were talking about before with local variables and how functions in Python can have side effects, how they can change the things that you pass into them, right? Well, if you do this, we're not actually going to be changing the original variable that we pass into it. We're going to be making a copy. We're going to be making a variable in local function scope and then assigning it to this list. Well, that's actually different than changing this one. And so if we print this outside here, we'll see that the Japanese style name should still be Yamamoto Isoroku,
Yes.
rather than
Yes.
actually being reversed.
Yes.
And to verify that, we can run with the print statements here. So you can see we didn't actually reverse the thing that we passed into it. And that's why the print statement needs to be out here, because if we comment this print statement out and instead we print down here, then we run this, it'll look like our code's right, except it's not, right? Because we're printing the value of the local variable right here. That's why I said our print statement to check whether or not we've properly done the reversal, it actually needs to be outside of the function.
Okay. Okay.
Does that make sense?
Yes, it does. It does.
Okay.
So
now, incidentally,
I need to print.
If we were to uncomment, if we were to not do it the improper way, then you'll see that it works inside. I'm about to say it should work inside the. Oh, okay. I know why. Let me see if you can catch this. So if you go to the documentation that you're looking at for this function, the reverse function, can you tell me what it returns?
Okay, I'll be right. Okay, reverse. It should return the list reversed, right? The same list changed with. Yeah.
Now, if it returns that, can you explain to me why it's not updating the variable right now? Because I just ran this, and you call Japanese name dot reverse, and in the print statement down here, the name hasn't been, or you know, not, I'm blind. It is. Never mind.
Okay.
I don't know what I was thinking. What I was going to say was that sometimes functions in Python don't update things in line. They make you reassign. But ignore what I was just saying, because I don't know why I did. I just read it incorrectly. Okay.
Yeah,
so
I understand.
The print statement here, the print statement down here works fine. But like I said, just because if we had done it wrong, it wouldn't have allowed us to know that we did it wrong. That's why we want it outside. Because if we put it outside, we're guaranteeing that we're printing the value of the variable outside of the function scope, which is the one that we want to make sure we actually reverse.
Okay.
Does that make sense?
Yes.
Okay. So now, having verified everything with print statements, let's try to do things with the debugger too. So I want you to go along with me so that you don't just watch me do it. So you remember where the debugger is on the interface?
Yeah. Yeah, I do. And what I'm trying to remember is how to set breakpoints. I think I can figure it out too. The previous breakpoints.
So to set and unset breakpoints, I'll just help you because this is something you just Google. Otherwise, you just click on the line number, right?
Yeah, I already did.
Okay, yeah, I was about to say, what previous breakpoints? Okay. So right now you set a breakpoint on line 276. And when code stops execution, where's it going to stop then?
It's going to stop before the last breakpoint I set. So I just set it on 291 so that it will execute 290 as well.
Okay. So you said it stops before the last breakpoint you said. What about the first breakpoint you said?
It starts executing from that first breakpoint.
So it's going to execute all of the lines before we get up to here, right? So it's going to execute. It's going to see a breakpoint at 276. And then are you saying it's going to execute from 276 to 291?
Yes, that's what I thought I did.
So it actually stops before the first breakpoint you set, not the last breakpoint you set. So it stops before every breakpoint. So all breakpoints behave the same. There is no like quote unquote first breakpoint and last breakpoint or anything like that, because you could put as many breakpoints as you want in here, right?
Okay.
What the thing executing the code will do is it will stop execution. It will stop execution
there's a breakpoint
right before the line on which you have a breakpoint. And so if we run this on line 276, we should be stopped on line 276 without executing that statement. Oopsies. So I just ran it, which doesn't do any good because to actually see the debugger and get the debugger hit, you have to run it from the debugging menu. Okay, so if we add the breakpoint here,
okay,
then you'll see that right now we don't have any variables defined because everything else is commented out in the file. And once we step over this, so we're not going to press continue, which would take us down to the very bottom here, but we're just going to step, and that now we'll have this defined, the list Japanese name containing that list that we just assigned with the assignment operator there. Okay, so how about we go through line by line here rather than just jumping down to the breakpoints at the end. So if we step again, we are going to go down to the bottom here. This was that other breakpoint, but it's not going to execute anything because this is a function. The function is not going to execute until we call it, which we're doing right here. And so when we call the function, we're going to jump inside of it. And now we're inside the function. And so we still have this variable in scope, but this variable actually isn't different than it was before. Why? Because it already existed and we're passing it, and it's a list, which means it's not passing a copy of it. It's actually passing the real thing. That's how we decided we were going to think about argument passing in Python. So now we're going to execute this line that says reverse, and this list that right now says Yamamoto Isoroku should now say Isoroku Yamamoto after we execute this, right? And you see, we only have one variable right now, not two, not a local copy and a global copy, but we just have one. And so now when we step, we see that we've reversed the name there, right? Okay. And so now after these two lines, we should have a variable called first name and a variable called last name in scope as well. You see, indeed we do. Okay. And then we should now have a variable called Western style name string, which concatenates those two things. Okay. Now I see a problem. Do you see a problem?
Yes. It's still printing. It's going to print. It's unreversed. It's not the way it should be. Yes.
And let me stop and let's see if we can figure out why. Okay. So if we
I think I know why.
Okay, you want to try to explain it to me?
Yes, I had already reversed the list. So the first name should have just been Japanese name at index 0.
You
and
want to
last
try
name
to
should
make
have
the
been
change?
index 1.
You want to make the change, and then we'll see if we still have that problem.
Okay.
Okay. So now you've switched it. I set a breakpoint on 286, which means we should stop after we've gotten the two name variables here. So we're gonna go ahead and run. And now our first name says Isoroku and our last name says Yamamoto. So when we do the concatenation, indeed, now the string matches the list. So I'm glad you caught it so fast, because that sort of thing right there can be really tricky sometimes if you're not sure why the values aren't what you're expecting. But indeed, it's because you did the reversal first. So if you had put all of this above the line that reversed the list, then you really would need to do it in the opposite order. But
yes, and there's probably a way to clean up the code, possibly. Instead of creating the variables, I might have just created Western style name string and then done Japanese name 0 plus space plus Japanese name 1. So
indeed, you can do that.
2 lines of code.
And that would probably be the way that most experienced programmers would do this. That is, here, I'll do it right here. What you have is actually fine. But a lot of the times, if you don't need to create variables, most people won't. And sometimes it can make the code more readable if you do, but there's absolutely nothing wrong with what I just did right there. where you just use the things directly, right?
Yes.
And that's probably would be the more preferred style for most people, just because it's shorter, right? You don't have extra stuff in the code that's not really helping your understanding any, because you don't actually need separate variables to do this. You can just do it directly. But the way you did it is absolutely fine. There's nothing wrong with this. Some people, even programmers who've been at this a while, would still probably do it this way anyway. So the reason for that is because, technically speaking, this is more readable. What this is doing is easier to understand. Why? Because, you know, we might know, oh, the first index of this array is going to be a name, but maybe someone who's coming across this code for the first time doesn't know that. And so if you say that it's a first name and you say that this is a last name, well, then when you stick the first name and the last name together, it's very obvious what you're doing. And so there's kind of pros and cons, right? All right, so the final test of our code here, the final test of our code will be to make sure that it works with a different name, right? So the name I used here, fun history fact for anyone who knows who this person was. This was the Japanese general in charge of the Japanese Air Force in World War II. So very famous. He was in charge of the operations at Pearl Harbor and the Battle of Midway. History people rejoice. You know, this actually has nothing to do with, we're calling it a Japanese name, so we probably ought to go find, you know, another Japanese person.
Yeah, we could always use
how
that.
about this? Oh, I don't know if I'm going to spell this right, but right now we have the family name. So Miyazaki is a really famous Japanese director, right? How do you spell his first name? I'm not actually sure. So you'll see that Wikipedia actually westernizes the name, but then writes it in the kanji reversed. So Hayao. Now, the other thing that we had mentioned was that if you had just hard-coded the name here, it would have actually worked for the input test case, right? But now it wouldn't work for this one, now that we've changed the name. So let's see, before we return the string, let's see if all of the variables in scope look right. So now we've changed the name to Miyazaki Hayao, the famous director, and we want to make sure that our function still has the right variables. So now this is the input array. You see that that's the order: family name, personal name. And now at the end of our function, right before we return, we see that now the array has been changed. The first name is Hayao, which is correct. That's the personal name. And the last name is Miyazaki. So it looks like it still works, even though we've changed what the input is.
Yes.
Okay, so are you comfortable with this function? You feel like you got everything?
Yeah.
Okay, so of course, the things that we're testing here, right? We're testing, do you understand that when you pass a variable and then you update the variable inside the function, that it actually changes the variable outside the function? That's one thing that we're testing here in this function. We're also making sure you understand indexing, and we're making sure that you understand what string concatenation is. So there actually weren't any conditionals in this function, but that's okay, because the next example will have lots of conditionals. So we'll leave this. We don't actually have to comment it out or anything. And does it make sense how we are checking things in the debugger?
Yes, it does.
Most people, most programmers, I would say, will, once you are developing in a development environment like this that has a debugger, you'll almost never use print statements anymore, just because the debugger is more powerful. And you don't have to change your code in any way. You just have to run with the debugger. So that is what I would 100% recommend you get in the habit of. Rather than trying to test your code with print statements, test your code with the debugger instead. Because it lets you step through it and lets you see how things change over time. And you don't have to waste any time writing print this or print that. Does that make sense too?
Yes, it does.
Okay. So next function is going to be writing a function that returns if a given year, I should say, passed in as an integer, is a leap year or not. So first thing, do you know what the modulus operator is?
Yeah. Okay. It gives the remainder
Right. And so if I have if I have a variable called remainder and I do something like 7, and then the modulus operator in Python is 5, or sorry, is the percent sign, then what we would expect
is 2.
This should print out what?
2.
2, right?
Yes.
Yep. Okay. So this is the modulus operator. You'll need to use this here. So the first thing I'll do is I want to make sure that we understand the rules for calculating leap years, because that's kind of tricky, even independent of any programming whatsoever. So you're welcome. I did put a link to a WikiHow article here. You're welcome to read the whole thing, but you can also condense that entire article down into this paragraph right here, which says that if a year is a leap year, if it is evenly divisible by 4, unless it is a century. So, for example, 1900. So if it's evenly divisible by 4 and it's evenly divisible by 100, meaning it's divisible, that is, it's a century, but not by 400, it's not a leap year. But if it is evenly distributable by 4, 100, and 400, then it is a leap year. And so a good example year that's actually reasonably close to us is the year 2000, because that is evenly divisible by both 4, 100, and 400. However, the year 1900 is divisible by 4 and 100, but not by 400. And then the year 1896 is only divisible by 4, not 100, and not 400. And if we were to do something like let me make another test case, actually. So we should also be testing. This is something you'll have to accustom yourself to, is coming up with test cases for your code. You want to make sure that your code works in all circumstances, right? So the year that I just put here, 1897, this isn't a leap year at all because it's not even divisible by 4, right? So this is very obviously not a leap year. At least the rest of them are divisible by 4. So they're potential candidates. So I'm not going to tell you how to do this one either. There are probably different ways in which you could set up the logic here, different ways in which you could organize the conditionals. Some may be a little bit more readable than others, but they're usually, well, I don't say usually. Usually there is kind of a preferred approach, but there's not only one right answer. There's not only one right way to do things. Usually you can come up with several different ways in the code to do the same thing. So I'll leave you to it a little bit. And you let me know if you have any questions about how the logic for determining if something's a leap year works or not.
Okay.
And by the way, there's a reason why we just talked about the modulus operator.
Oh, yeah, that's true.
And so to check if something's evenly divisible by something else, what should you do?
I use the modulus, not
okay.
Yeah.
And what should the return value of the modulus be? Okay. There's one more problem with what you're doing. So you're using 1 equal sign. What does 1 equal sign mean?
All right. Another thing I miss.
Yeah.
Yeah. Mm. I feel like I'm forgetting something here. So far, I think this will test whether the year is a leap year or not, but it seems like something I should do and I'm not doing.
Okay, so this gets one case, right? This gets the case if the year's like 2000. So you see how I put 4 test cases up here?
Yes.
How about we test each one? So let's do variable test1 is going to be equal to your function here for all of these variables. So you see how I've named the variables? Leap year 1 should return true, not leap year 1 should return false, not leap year 2 should return false, and leap year 2 should return true. You know, let me group it a little bit differently. Let me group it like that. Okay, so if we organize things like this here, we're going to say test 2 is going to be equal to, does it make sense what I'm doing here?
Yes.
In fact, all of these here should be outside. You can also just print them directly. You wouldn't have to use temporary variables like this. But if we do this, do you agree that we should expect false, false, true, true, right? If our function is written correctly?
Yes.
Let's see what we get.
So it doesn't actually test.
So logic's right for this one. Now, can you explain to me why it's returning none for the other ones rather than false?
Because it's not actually able to test anything there. Plus, even when it does, it doesn't really know what to do.
So let me show you. So if we set a breakpoint in the very first thing here, you see how you only have one return statement? So we want the function to return two different things. We want it to either return true, or if it's not going to return true, we want it to return false. So first, let's fix these here. How can you change your function to return false if this conditional doesn't execute? Yeah, not a trick question.
Yes. So the first thing, and that was why I was a bit confused, was I should probably set a false statement or a true statement outside the global scope before the function, or in the function, I would actually create multiple scenarios, in which case, if something is, so there will be a number of if-elif statements, and if not works out, then there should be a return false.
Okay. So what I'm talking about is we want to return false at the end, right?
Yes.
If nothing is true, we want to return false. So this should fix the nones here, because it'll mean if this case is true, then we're going to return true. Otherwise, we're going to return false, right? So now we change the nones to falses. That's the first step here. So now our function either returns true or false. However, you still see that it's wrong, because our function is not recognizing test 3 as a leap year either. Right?
Okay.
So do you remember the discussion we had where we talked about when you have Boolean expressions, how sometimes it's easier to use variables that you've named to make the logic clear?
Variables that I'm
talking about?
Not yet.
Let me scroll back up then.
Okay.
So in our discussion, the example we used was the stuff with the book. Like we were testing, or not the stuff with the book, we were testing all of these things that we were going to do on strings. And then we wanted to see if the string like started with a vowel and had length less than 10 and contains at least 3 O's. And you remember it's like picking up right around line 224. We talked about how when you have these expressions in the conditionals, sometimes it's better to name the variables rather than calling functions directly. And it's actually faster as well. Let me just explain here rather than having you figure it out, because I doubt you've kind of looked at this before. So right now, you see how you're doing this operation here, year mod 4, double equals 0. That's a Boolean. This is a Boolean, and this is a Boolean. What happens if you change them into? What happens if you want to do all of these checks again, right?
Yeah. So using variables would make that easier.
Because now if you want to check another case where, for example, it's not evenly divisible by 400, well, you're going to have to do each one of these checks again. And every time you do the check, it costs operation time, right? Whereas if you just use a variable, it doesn't have to do anything. So how I would lay this out is divisible or, oops, that's not the Python way of making variables. Python naming convention uses underscores like this.
Okay.
So we would set this variable for that. Let's do that. Probably easier than trying to type out 100. You see what I'm doing? So we're going to pull these things out into variables. Then we're going to do the same thing here.
I try to finish it from there.
Yeah, you sure can. I'm not going to do any more. I was just going to get you on the right track because you are going to have to reuse these variables. You're going to have to figure out how to do the other case that should return true. All right, I'll leave you alone for a bit, and you should look at the test cases and figure out how to make the ones that should return true.
It doesn't updated here yet. So
Are you connected to the internet?
yeah, I'm using the same laptop for Zoom and everything.
You could try just refreshing the page, maybe.
Let me do that.
And wow, I have typos. I can't spell. Divisible. Oops. Well, it looks like maybe it was my internet that hadn't updated. Ah, no.
I know what to do, so I can just repeat
Okay.
it.
Yeah, you can redo the changes there. I'm sorry. It must have not pushed on my end, not your end. That's weird. Ah. Okay.
Yeah. All right. So let's start this.
All right, so you want to try running it and seeing if that gives us the right thing?
Not yet. I'm not done thinking about it. Okay. I think I can try it now.
All right, so it gives us false, false, true, true, which is what we want. So you want to sit there and look at it and make sure it smells right.
Yeah, I think I want to try a use case that's probably not, but I think it seems okay to me now.
So let me read that paragraph again. It says that a year is a leap year if it's evenly divisible by 4, unless it's century. If it's evenly divisible by both 4 and 100, but not 400, it's a leap year. But if it's evenly divisible by both 4, 100, and 400, or sorry, then it's not a leap year. If it's 4 and 100, but not 400. But if it's evenly divisible by all of them, then it is a leap year.
Yeah.
So
I was wondering
if case is not divisible for 100, 400. This one is divisible by 4, 100, but not 400. One is just divisible by 4, and this one is
Yeah.
right.
Yeah, I'll bet 1996 works.
So feel free, you can change any of these. Have you typed anything?
Yeah. Just yeah, I tested it too. It works right. I changed 1896 to 1996 and it's still growing. Is there something? There's something I don't see a way to make this a better code, or is there a way?
So there are differences. This is one way. What you've done here, let me briefly explain here a concept called test-driven development. So you see how we've been writing our function according to a list of cases we want to test, right?
Yes.
So yes. Eventually we'll get into a concept called unit tests, which are in a programmatic way. You write code to test your other code. And what the tests are supposed to do is they're supposed to make sure that you test all possible logic branches in your code so that the code always does what you want it to do. It's a way to kind of double check yourself and say, if I give my function this input, what should my function return? That's what a unit test is. You test functions in code. You say, if I give it this input, this set of circumstances, what will my code do? And you want to expect your code to do a certain thing, and then you want to make sure that your code actually does that. And so here, we would want to, if we were writing unit tests, what we'd want to say is that in our unit test, if we give it the value 1897, our function should return false, right? And if we give it 1900, it should return false. And if we give it this, it should return true. And if we give it this, it should return true. And if we pick our cases well, it means that we will test all possibilities in our code here. Let me show you a second way to write this function. This way is good. And what this way does is you're testing the true cases. Otherwise, you're returning false. And the nice thing about this is you don't actually have to handle 4 cases. You only have to handle 2, right? Because if it's not one of these, we don't care about the other cases because those cases all return false, right? So you only have 4 cases here. Let me show you a couple other ways to do this. This one, what I'm going to do now is more verbose. This isn't what I would recommend. However, arguably, this is the one that most closely maps onto the logic of the paragraph. So the paragraph starts by saying that if something is divisible by 4, but is not divisible, like you could actually make an if statement for each one of them, right? Again, this is not how I recommend you do it because it's kind of repetitive. Is equal by 100. So we said this one should return false, and well, actually, in this case, we can't do this right here. We'd have to do this one after. We have to do this one after this if statement. Otherwise, it wouldn't execute properly. Because otherwise, if we put this, let me show you why this won't work. If we put this here, then when we run this on the test case of 2000, it will return false. We won't. Well, let me.
Yes, it will.
Do you see why? Because if we run this with 2000 won't hit this case, but it will hit this case. Because 2000 is divisible by both 4 and 100, and then it'll return false because it won't ever even hit this one.
Yes.
So this approach that I'm doing here, where you make a case for each situation that you can think of, this is just inefficient code-wise, because we're going to be checking all of these things when, honestly, if it's not either one of the true cases, we can just return false like you do up here, right? So this is pretty clean. This is pretty easy to understand. So this way, where you're making a case for everything, right? So, and in fact, to be super clear here, you could put the reason why we're not going to do something like after the and not divisible by 100 and not divisible by 400 is that because if something isn't divisible by 100, it's not going to be divisible by 400. Does that make sense?
Yes.
Everything that's a multiple of 400 will be evenly divisible by 100.
Yes.
So the really dumb way to do this, is to write out literally all of the variables for each case, right? So if it's divisible by 4, but not 100 or 400, if it's divisible by 4, divisible by 4 and 100, but not 400, and if it's divisible by 4, 100, and 400. You see what I'm saying? Like you write out each one of the cases specifically.
Yes.
Are you tracking?
Yes.
So arguably, this works fine too. It's just a little bit more verbose. And the thing is, like I said, we don't actually need to check the 400 case when we check the 100 cases, because if something's not divisible by 100, it also won't be divisible by 400. So what I'm saying is that this code that we have written up here is actually shorthand. It's actually shorthand for that, right? Those two things are equivalent.
Yes.
Because by definition, if something's not divisible by 100, it won't be divisible by 400 either.
400, yes.
Mm-hmm. Okay, so this is one kind of, I don't want to call it dumb. It's just a little bit wasteful and repetitive, right? So what you have, definitely better than that. Another way in which people might do this is they wouldn't do variables at all, and they would actually nest the logic here. So the first thing they do is they check if the year is divisible by 4, like this. And then they would check if the year is divisible by 100. Like this. And after that, if the year was divisible by 100, they would check if it's divisible by 400. And so that is the case in which all three are true. And then if we jump to the else here, that means that the year is divisible by 4 and 100, but not 400, which we said we should return false. And if we jump to the outer else here, that would mean that it's divisible by 4 and 100. You see? Oh,
Yeah.
I apologize. I am writing C# code. That's habit right there.
That's an interesting, less verbose way to put it.
You follow how this one works?
I want to try and see if I can. So
let's see if we get the right thing. We should still be in false, false, true, true, right? So if we change which function we call and we run this, we do get false, false, true, true. So this is the correct logic. Now see if you can wrap your head around it. This is the other way in which you would write it, aside from the way that you did it. I like your way better. It's more readable. But this is actually arguably more efficient in terms of how it runs, because it only checks each thing once.
Okay.
You know, let me. Remember the website I told you about earlier that lets you build flowcharts from pseudocode?
Let's build flowcharts with pseudocode. I think it's up here. Yes.
Mm-hmm. So.
Yes.
Fortunately, it does require Okay. Does this help you understand it any better?
It's a lot easier to. So if it's true, if the year is divisible by 4, then you check whether it's divisible by 100.
Mm-hmm.
If it's divisible by 100, then it's true. It's a leap year. If it is divisible by 100, we check to see if it's divisible by 400. If it is, it's a leap year. If it is not, I like that.
Mm-hmm.
Make sure that was it. So this is a different way to write the same thing that I wrote.
Indeed. And this way doesn't have any variables, but this is the logic of it. What I will say is that if you were to just look at this function, this with the flowchart is exactly what this code is doing. It's just when you squint at the code, it may not be quite so immediately obvious, right?
Yes.
This is why the flowcharts are super helpful. I will say that in terms of if I were a peer reviewer on a project and you were submitting your code for things and you said, hey guys, our customer wanted us to write a function that gets a leap year. And if you were to submit this code and this code side by side, I would pick this one. This one is easier to understand. Now, in terms of efficiency, this one's actually probably a little bit better because you don't do extra checks here. You don't have to check Boolean so much. However, there isn't really a wrong answer here. Both of these would work fine. So,
Can I just throw in a question at this point? That I hear something about how one way of writing a code is better for the computer in terms of memory, and another way is not. Does that apply here?
I believe so, because here you're creating 3 extra variables, right? And here you create no extra variables, and you don't check anything more than once, right?
Yes.
So here we are making 3 extra variables, and we're checking if something is not divisible by 100, right? That means that we're negating a Boolean variable, and we're doing the logic here. We're doing it. We're doing like a Boolean and. Whereas here, all we're doing is checking this, and then we have the true path and the false path, the true path and the false path, the true path and the false path. We don't have anything extra. However, and I'm quite opinionated about this. Computers nowadays in modern like server architectures, server space is really cheap. Processor power is cheap. I mean, like you shouldn't be purposefully inefficient. However, what is expensive is developer time. And if you in the future want to go change this function in some way, if you have good variable names and it's very clear what the logic is doing, this function is much easier to modify than this function is. It's much easier to wrap your head around and see exactly what the code is doing. It will take someone, even an experienced developer who's been at it for years, they will still have to look at this. And in fact, many people, like me at least, I would 100% use a program like this to make it a flowchart so that I can actually understand it, rather than trying to sit there and think about what this code is doing. This is not easy to understand particularly, which means that if you get an intern from college, someone who's had a bit of programming, they know how to code, and you would want to give them tasks like updating a function or something they can actually do so that they get something out of their internship, and you get some of the tasks done on your project. Well, if I tell them, hey intern, go update this, their eyes are just going to glaze over completely, because they're not even going to know what the code does, right? And that's why, in my opinion, my professional opinion as a programmer, much better to emphasize readability in code and understandability. How obvious is something? You would want to comment it as well. If you use good variable names and you use clear logic with the variable names like this is easy to read and understand. So first, we're going to get whether things are evenly divisible by 4, 100, and 400. And if it's divisible by 4 and not by 100, then we return true. Otherwise, if it's divisible by 4, 100, and 400, we're going to return true. Otherwise, we return false. It's super easy to understand because everything is very readable. Whereas here, implicitly, depending on where you are, right? So if you're inside this first if, then year is divisible by 400 positionally. Okay, so if you're inside the second if, then year is divisible by 100 implicitly. So that's why this else equals evenly divisible by 4 and 100, but not 400. Because if you're already inside of this if, then already divisible by 4 and divisible by 100 are true. You see? So you can track the logic, but it just takes a sec to wrap your head around.
Okay.
So, I mean, like I said, I don't know if I would actually straight up reject this code in peer review. There's nothing wrong with it. But if I were myself programming this on a project that I had to maintain for 10 or 15 years, I would 100% do it this way. Because I think it is clearer. It gives you a better understanding of the logic. And as long as you are testing it against a set of cases that is comprehensive for the thing that you're testing, that way you'll make sure that if you ever do change this code in the future, it will continue to print the right thing.
Okay.
Does this make sense?
Yeah, makes perfect sense.
All right. So the reason why I thought this one was more challenging is because I wasn't sure if you were going to try to do it this way. And people who try to do it this way first with the nested conditionals always get confused, because nesting of conditionals it's kind of challenging. You have to keep track of what's true in your head at what point in time.
Okay.
I actually kind of wasn't expecting you to do it this way first, but I kind of, what's the best way? I put my hand on the scale by telling you to define variables. Because if you define variables it naturally leads to doing it this way rather than doing it this way, right? Because yeah, there's no variables here. So that's my preference. In fact, that's why I kind of made a stink up front about using Boolean variables for readability. I don't even know if I'm trying to think about like how many developers would agree with me. I think I happen to be right from like a code maintainability perspective. Gosh, where do we even talk about this? Yeah, up here where we were talking like this with the readability. I think it's more readable 100% for sure. But you know, maybe not everyone would agree with me. So I'm going to sign off for today. Got to go get ready for work and stuff. But now we've finished the practice problems here for these functions here that didn't involve any loops. So you've done three problems now. So, you know, in fact, we can uncomment this. And if you ever want to go see the example, oops, uncomment, not comment. If you ever want to see the examples you've done, well, now you've written 3 functions here. They all do different things, you know, different considerations in each one. But hopefully it's clear, the logic in what you've done here. And, you know, you're making progress, right? So if you'd come into this, you know, let's say a full week ago before we started any of this, do you think you would have had any idea how to do these?
I'm pretty sure I wouldn't have. I would have frozen.
So you think this is helping, right?
Yeah, it's great. It's great. I think I'll go find some more functions to write.
Okay. Do you want me to come up with some more examples before tomorrow?
That'd be great.
I could do some, and then you could try them this afternoon as well. So I'll check in maybe over my lunch break at work. So if you check the document later in the day for you, I will add some more right underneath this one where we did the leap year stuff. Before, because we haven't done loops yet formally. I already have several practice problems for once we've done loops. You'll see down there, but I'll make some more that are just functions and Boolean variables and stuff. Now, I will say that something that you will want to practice is you're going to want to practice getting faster, right? Because you have gotten all 3 of these, and I haven't helped you that much when you got them. But in the real world, I mean, you saw I wrote this one in what, like a minute? And I mean, I'm not trying to say I'm great or anything, but anyone who's been a developer for a while will, you know, be able to look at one of these problems. These are going to be considered easy peasy problems, like for, you know, practicing developers who are employed, right? Like you should be able to knock out these functions in a minute or 2, probably. And I'm not trying to intimidate you. I'm just letting you know that that's where we want to be eventually.
So I want more problems to work on.
Right. You're going to want to practice to the point where you can take in a situation and you can kind of translate what the question is asking you to do, what the task is, and you can translate it into code more quickly. It's not so much that you wouldn't be able to get it otherwise, but speed is an important part of this because eventually you're going to have to be doing lots of functions, building a much more complex system that's not just one thing, but maybe 5 or 10 or 20 or 100 all working together. And if it takes you, you know, 15 minutes to write one, well, then if you have 99 left, suddenly that's pretty scary. Whereas if it takes you a couple minutes to write one, then having another 99 isn't such a big problem, right? So it's just going to be a practice thing. There is not a lot more to say other than that, you know, like I think you're doing quite well considering how fast we're moving here, but eventually you're going to want to be fast too. And that's the thing is that once you start quote unquote thinking like a programmer more, the code will just come out of you more rapidly. It'll just be, oh, if I want to check this, if I want to check if this is true and then do this, well, that's just a conditional. And what do I need to check to make that conditional? Well, I can check this thing and then, you know, or it together with that thing or this thing and it together with that thing. And like, you'll just start seeing the relationships a little bit more in your head, which should let you hopefully translate things into code more quickly.
Yeah, thank you.
All right, well, I will try to add several more problems here. I'll add them under the one for leap years. You know, maybe not in the next hour or so, but hopefully this morning sometime when I have a break between meetings and stuff. And then you can try to do those before we get back together tomorrow. And then if you have questions, you can come with them. I think that'll be a good plan.
Yeah.
All right, well, I'll sign off then, and we'll pick this up again tomorrow.
Thank you so much.